So to look at what a graph of logarithmic function would look like, we are going to do a kind of basic example. Log y equals log base 3x, or f of x equals log base 3x. So just like we usually do to kind of first get an idea of what our functions look like, let's just pick a bunch of different x's, see what happens. Now here, normally we do -2, -1, 0, 1, 2, but that is maybe not going to work out best for us, because remember what we just talked about with simplifying. I want to pick things that my base would be 3. So let's say that I have x is, well, let's start with 3. Log base 3 of 3, that's like 3 to the 1 power. My y value would be 1. How about 9? Log base 3 of 9 is the same as log base 3 of 3 squared, so that'd be 2. How about 1? Log base 3 of 1. How could we rewrite that? That would be log base 3 of 3 to what power gets me 1? 3 to the 0 power gets me 1. So that would be 0. So log base 3 of 1 would be 0. And how about a third? We did one kind of like that before. Log base 3 of a third is the same as log base 3 of 3 to the -1. So that would simplify to -1. Do one more. How about a ninth? Log base 3 of 1/9. That's the same as saying log base 3 of 1 over 3 squared. Log base 3 of 3 to the -2. Okay, so hopefully you're kind of seeing a pattern here. So let's 2, 3, 4. Okay, so let's put on some points. 3, 1, 9, 2. Even if you think about it, 27 would be the next kind of nice one that would only go up to 3. So it's going up really slowly. And then 1, 0, a third -1, a ninth -2. If you can imagine, I'm never going to be able to plug in an x that is negative. So this is going to just keep approaching the y-axis like that, and then it's going to increase really slowly. So just like the exponential functions, those increase really quickly. Logarithmic, I mean, they increase pretty quick, but then once it hits that point 1, 0, it's going to increase really slowly. So it has patterns of some natural things that come up that increase slowly.